So, sir. How'd you get that? Sit down.
Do you have any idea what you're doing?
No, but it seemed pretty interesting. What am I doing? What is this? Integration by partial fractions? How do you do that?
How would you start this?
Well, I thought you would just start with U substitution.
But you can't do that.
Why not?
Because this is not the derivative of this.
Okay.
But this has a higher degree than this one, right?
Okay.
So you have to factor the bottom.
Okay.
So you're basically going to start by factoring this bottom part. So we still have the top, but on the bottom instead we have x minus 3 times x plus 2. And then this is equal to, when you split it apart, you have the a over x minus 3 plus b over x plus 2. Now what you do here is then you want to find the common denominator. You multiply to give it the common denominator, which you'll multiply this side by x plus 2 over x plus 2, and multiply this side by x minus 3 over x minus 3. So you won't have to write the same base, but basically you have that a times x plus 2 plus b times x minus 3. And this is all still equal to this up here, because you need to solve for your a and your b. Now what we want to do is we want to set the a or the b equal to 0 first, whichever one you do is whatever. So let's do the a first. The x is equal to negative 2, which makes this whole thing 0, making a equal to 0. So if we set x equals negative 2 for the first one, then we have b times negative 2 minus 3, which is just negative 5, equals 3 times negative 2 plus 11, which this equals positive 5. So we have b times negative 5 equals positive 5. When you divide this out, then b equals negative 1. Now let's go over here so that we can solve for a. So you want to set b equal to 0. For this one you have x equals positive 3. So then you plug positive 3 in for every x in the equation. We have a times 3 plus 2, which is just 5. Plus the b, which is 0. Which equals 3 times 3 plus 11, which is 20. So you have a times 5 equals 20. When you divide that, a equals 4. Now let's go down over here. We plug those back in for the a and the b. So a equals 4. So you have 4 over x minus 3 plus negative 1 over x plus 2. Since this is a negative 1, we'll just do minus 1 over x plus 2. You're still taking the integral of all of this. So basically when you get to this section, you need to bring the 4 out so that the numerator is 1, because the numerator needs to be the derivative of the denominator. So we have 4 times 1 over x minus 3 minus 1 over x plus 2. And then we use some natural log rule, and it makes it bring the 4 out in front before you do anything else. Natural log of absolute value of x minus 3 minus natural log of x plus 2, and then you always put the plus c at the end because indefinite integral.
So here's our next example. This one you need to use long division to change the degrees because this degree is the same as this degree. Basically, then you just divide these two. This can go into the x squared one time, so you bring down that x squared minus 16. You have to make sure you subtract it, so then this minus this is nothing. Negative 1 minus negative 16 is a positive 15. You can't put this into the 15, so you just bring up the 15 over the x squared minus 16. We're going to bring that over here so that we can integrate this first, because we have this one that's easy enough to do. So you just factor this like that, split them apart with the a and the b like we did in the last example. All of these steps just like the last example. Common denominator, bring them down here, set them equal to 0, solve for a and b, plug those back in. Where did we do that? Plug those back in up here. Integrate this, we get this answer, and then we need to add in the integral of the 1, which is just going to be an x. So we'll have a plus x at in this part. So we'll have x plus negative 15 over 8 natural log of absolute value x plus 4 plus 15 over 8 natural log of absolute value x minus 4 plus c. And there's a final answer.
The cow is smiling.